Here is the third lesson about electrostatics. We'll talk about the electric field here. Just like gravitational field, the electric field is something like that. Let's talk about more about the field concept. In the past, scientists think that the force is long-distance force. That means if there is a mass big M, yeah, and if there is a mass small m, occurs suddenly. The small m occurs suddenly, and the force acting on them is instantaneously, without time dilation, without time delay. The force act on them is instantaneously. But Einstein told us that the maximum speed is the speed of light. This transfer of signal. If we have to tell the big M that the small m is here, and then they add the big M adds a force on small m. By relativity, we know that the maximum speed is the speed of light, so the force is not instantaneously. And how to solve this problem? So the scientists introduced the concept of field. And then what is field? In the theory of the field, if there is a small m, and it will induce some electric some field around it. If another mass is in the region of the field line, in the region of field, and a force will add on it. How to calculate the electric field? By the definition, it is the electric force acting on a positive test charge Q0, placed at that point divided by the magnitude of the test charge. And then what is test charge? We will have initial a charge Q, and then we place another small test charge Q0. Be aware that the charge of the Q0 is very small. But why? If the charge of the Q0 is very large, and we will distort the initial charge of Q, it will cause a redistribution of the charge Q, just like the charging by induction. Light charge attracts and a light charge repel. We don't want the charge is distorted, otherwise the electric field is depends on the test charge. It's not universal. Then by the Coulomb's law, you can see that the force is equal to Ke, the coefficient of electrostatics, times Q0 over R square. And by the definition of the electric field, is the force divided by Q0. And you can see here is the equation of the electric field. It possesses all the properties of the electrostatic force. Its overall is US square law and depends on the initial charge Q, and its direction is along the R head direction. And it is also another very important properties is they can be added as a vector. At any point P, the total electric field due to a group of charges equal to the vector sum of the electric field of the individual charges. That means the superposition principles is related in the electric field, and we can express as this equation. Now you can see this example by yourself. You just press the pause button and you can see this example. Also this. And then in the next lesson, we will talk about the electric field of a continuous charge distribution. In these lessons, we just talk about a point charge, not a continuous charge distribution. Yes, that's the end of these lessons.